Okay, we're in section 5. It's a really, really brief lecture. Basically, it's just reviewing what you've done in Math 121 with volumes of revolution. I'll go through this, a really tiny lecture. We'll go through some examples. Then there'll be a chance to try on your own. And again, I want to encourage you that, you may want to come by during office hours. You may want to read a textbook. You may want to go to the web, whatever helps you. You need to learn how to do this material though. So I'll go through a whiteboard explanation of what expected in this section of the notes, which is a very brief section, by the way. So let me give you a new share. And we're going to go to my whiteboard now. And we're here. Again, really short lecture, all right? So it basically says the material was covered in Math 121 and it's going to be really reviewed here. These pictures I just lifted from a textbook. Standard calculus textbook, the pictures always look the same. And certainly I was shocked to learn when I was speaking to one publisher about this. They say that these images are really, they farm it out to someone to do it. And I guess the person doing it, they don't get paid much for the pictures, by the way. They just generate them and then they give the picture to the publisher. But anyway, I see some nice pictures over here. So it says, find the volume of obtained by rotating the about the x-axis region. Oh, I guess I got to draw a picture. And so someone says, well, you have a picture. Why are you drawing a picture now? Well, you need to be able to draw a picture. And what do I have over here? I have a problem. It says, I have this function over here, y equals the root of x. This is part of visualization. And they have from 0 to 1. So I'm going to put 1 over here. And we're going from 0 to 1. I clearly see the region they're talking about. This is the region. Now, what are they doing with the region? They're rotating this region, and I'll read it to you. It says, find the value of the x-axis. So they're rotating it like this over here. So what I would do is I would draw a picture of a rectangle. Everything kind of boils down to a rectangle to me. Now, if you rotate that region, what are you going to say? You're going to see a disk. Looks like this over here. And I got to figure out the volume of that disk and add them together. So the volume of the disk, and I'll go through it slowly. We're going to be adding the disk. Whoops, let's go back to black ink. We're going to be adding the disk from 0 up to 1. And the thickness of the disk is dx. And then what I have to do is I got to get the surface area of that disk, which is relatively simple. It's going to be pi r squared. What's the r though? The r actually corresponds to a y. What's the y? It's the root of x. I think I can do the integration. Let's go through this. Pi 0 to 1 x dx. I keep moving through. Pi x squared over 2 0 to 1. These tend to work out pretty nicely, by the way. What do you get over here? Pi over 2. What I'd recommend is certainly when we're looking at these notes over here in the blue area, put the work down. Certainly have been discussed. Again, if this was an exam paper, this is what my exam paper would look like right over here. And that's it. There wouldn't be much there. There's no way I could draw those pictures they've given me there. There's no way I can do that. All right. So that's it for the lecture. I mean, really not much else to say about that. But that doesn't mean, if I speak briefly about it, it's not worth anything. It's something you need to understand, something you'll be able to do on your own. Thank you.